So as discussed in last video, my account is blocked, real-time VFX account. So I just switched to this site, the community of Unreal Engine, that they're on site. So there's a dev community. So in the forum, I found this question, someone facing some issue. So I decided to answer each and every question on this platform related to VFX because I can't do that on this platform. So every question I will found here, I will try my best to answer and make a video for you guys. So this guy asked that I need to implement the collision of particles themselves to get the effect of two water jets. Basically, this image you can see what he want. There's two emitter, he want collision here. So there can be different ways to do it. You if you want self collision, actual self collision, you can do. You can just download this content example of Unreal Engine. This is a huge project. In this, you will find this file, this map, and where you will find this position-based dynamic, where you will find how they are colliding self-collision of particle. And I have also a basic tutorial. If you'll see, this is my basic tutorial. So you can just type this and you will just redirect to my YouTube video, which is actually for only for members. You can check that video also. So let's do it with other ways, very cheap ways, or you can say we can cheat with it. So we are not self-colliding particles, but we can do something that can work for you. So there's two emitter. Okay. So what I'll do, I'll just take a Niagara and I'll just take this fountain effects. Okay, so I'll just call it FX1 because we will try two ways. I don't want to save it. So in this, again, this is not visible. I don't know why, but it happens with me all the time. So this is the fountain. I'll change something here. First thing, I'll just make this cone angle very low value. Then I'll make these maybe 700 and 700, same value, just 700 we can put. Then in the cone angle, this is just the Z. So I'll just also use the X and maybe 0.5. So this is 1 emitter. And let's just rename it. So I'll just call it red and also make the particles red. Okay. Second emitter, I will just duplicate it, Control C and V, and let's call it green or blue, anything. And in this one, let's change the color first. So I'll just use the green color and they have the same thing. So I want to offset it here like the image. So one is here and one is here. I want to make it here. So in the shape location, in the transform, I will just offset it on X, maybe 200. And then I want to change the direction of particle. So in the velocity, I will use minus 0.5 here. So we have the same particle now. We just need to collide here. So one way is you can just make a like custom module, and second way is you can actually collide with a planar, virtual planar that is called analytical planes. So first I'll show you if you can do it with a module, a basic module. So what you can do in the particle update of like in green, actually we need that in both, but I will duplicate it. So once we will create it for green. So I'll just take a scratch pad and just rename it distance check. So it will check the distance between these two particles and it should open here. So it will check the distance between these two particles, and depending on that, it will just modify the velocity. So we are working on the green particles, right? So what I'll do, I'll take particle attribute reader, and why I need this because I want to access the red particle position. So let's just rename it PAR short form so it looks nice. Then we want to access the position, so I'll take the position by index and just connect execution index. So we want every particle and just type here position, right? Then you can take the position of your green particle. So in this, we will access the red particle position and we have here green particle position. And let's just subtract from each other and just check the length. So after subtracting, we will have a length. And if this length is less than a value that we will call range, so I'll just make here a float and just rename it range. So this range is distance between red particle and the green particle. So if the position is less than that range, I want to do something. So for that, I'll take the if, and here vector. We want to modify the velocity. So that's why I'm taking the vector, and here boolean. So if this less than that, I want to do something. But if this is not less than that, I want the same velocity that we have already. So I'll just connect here velocity. Okay. Actually, let me just grab it, so make it bigger so you can see properly, right? So basically, if this is false, I want the same velocity. But if this is under the range that I want to do something it. So let's say you want to just multiply. So if I take the multiply this velocity and then connect. And then finally you will set the velocity of particles. So this is the basic module we have created. So we are just checking, we are subtracting particle, taking a length, and if the length is less or greater than some value that is range, we will modify the velocity. So in this case, you can take a float or you can take a vector. So let's take a vector and we will call it modified velocity. So this will be my modified velocity if particles are under the range. Let's apply it and I'll just close it. So now, first thing, it has a warning that it won't emitter name. So I'll just type red. And I'll set the range maybe because here I think 50. And see when the green particle is under the range of red particles, velocity is multiplying by 0. But I don't want that. I want the same velocity, but I want it to like collide back, push back. So I just make it -x. And let's do it same for the red particles. And here you need to type the green because you want to access the green particle. And here I will just, oh, because this is the positive x, you need to type here 1. Okay. And here you need to type 1. Let me check. Okay, this I switched actually green one. Yeah, I offset the green. So in the green one, velocity is positive, negative. It's negative, so I want it positive. So let's make it, yeah, negative. And let's make the range maybe 80 or maybe 60. And one more thing, let's make the this thing less. Yeah, let me just adjust these things. Basically, you can like I have adjusted these settings. So this is my 50 and this is my 50, and I'm just inverting the velocity on x. So this is if you specifically want that. Okay, and you can also like increase velocity height like that, and it will still work. See? So one way is to do this like this way. So you need to just, oops, you need to just create this type of module where you will compare the length depending on when you subtract position from each other. And if this is less than, then do something. If this is not, do something. So this is one way. And the second way is actually collision with the analytical planes. So I'll just, oops, I don't want to save it. And I'll just duplicate it. And this is my FX2. So in this one, I'll just delete these modules. And we have these particles, right? And let's make the height maybe 1 and 1, like that. So I want actual collision. So like for the green one, if I isolate and this is offsetted, so in the center, I want something and I want collision. So if you take the collision and here if you choose the analytical planes, there will be two planar and it has position and the normal direction. So I want in the center, that means if you'll see the position, this is 200 I have done. So that means I want exactly in the center. So I will make it 100 and the normal will be X. So it's colliding. Cool. And that second one is I want it on 0, like that. I think I need to make it. Oh, yeah. So basically, if you see this first normal, first planar, I have set the position 100 because this is 200 position where particle is spawning. This is 100 and then there's 0. And after colliding with this planar, because I have the X, let me just, one thing. Yeah. So basically, this planar is basically is here. Okay. And why it's standing? Because the normal is X and this is the X direction, that why it is X. If you put it on Z1, so this planar will be like that because this is the Z direction, this is. Okay. And then second planar is making like a ground collision because this is Z normal and I have offset it -10 because particle is spawning on 0, so it will collide it and it will not work. Okay. So I'll just, okay. And the same thing I'll do here. I'll just drag and I'll change it -1 and -100. Basically, I want it in the center. So this will be like -199. Yeah, 0 actually. And in this one, oh yeah, we need it actually in center because both emitter, I was a little confused. Both emitter is there. So they are colliding and they are also colliding with the ground, right? You can offset this like this. Red, see? So that's what you can also do. You can just make these local if you want and just drag it into the viewport. Then Control D and you can rotate and see. There this cool fountain. Cool. So you can also do that. So there can be many more ways to do this. So I hope you will find this helpful. Thanks for watching. Keep learning and bye bye.